this time on substitution, elimination, and graphing is because eventually, well, of course on the test I'm going to be specific and the problem will say solved by elimination, so Ashanti has to do that problem by elimination. But there are some problems in math class that he's going to get and he's going to see it and it's going to say just solve, and so he can use any of them. And so would it be easy to graph these two equations the way they are right now? No, we would have to do a little work to graph them. Would it be easy to do substitution right now? Is there an easy equation? No. There's no y equals or x equals equation. We would have to do a little work for substitution as well. So that's when we get to this third option, and it is called elimination. They've already done step 1 for us, but I'll still write it in the step 1 box. Line up like terms for all equations. So the y's need to be near each other. The x's need to be near each other. And the numbers as well. What does elimination sound like?
You're getting rid of something.
We gotta get rid of somebody. If you eliminate someone, you killed them off. So we've got to kill one of these variables off. How to kill them off? So step 2 says look for inverse coefficients. So like negative 3x and positive 3x would have canceled out. So if we had had negative 3x and positive 3x lined up, then the x's would have died off. So we've got to figure out a way to either kill off the y's or kill off the x's. We could kill off either one. Okay, if we wanted to kill off x, what will we need to multiply that top equation by? Negative 2? Positive 2, because we want them to cancel off. So right now it's positive and that's negative. We like them being different signs. So one option we could do is we could multiply everyone in that top equation by the number 2.
Even 3y?
Even 3y. Everybody's going to be multiplied by 2. Yes, dear. Yeah. Yes, dear. You don't have this packet? Here, I'll give you this page and then I'll go copy your new packet in a second.
Oh, this would equal to 8. Yeah, it is.
Okay. So if I multiplied everybody by 2, and I distribute that 2 to everyone, it's okay because, again, I'm multiplying everybody by 2 in the top one. So I would have 6y plus 2x equals 8. Are there any questions about what I did to that top equation? Now, I'll make you a whole packet when I do that randomly. Now, Maggie was right, and everything's going to end up canceling out, and life is great. But if we wanted to do this problem differently, if we went back to the beginning and we were wanting to get rid of the y's, what could we have multiplied the bottom equation by? Negative 3, and then the y's would have canceled out. So you don't always have to cancel out the x's. You don't always have to cancel out the y's. It's really your choice. Okay, so we have y minus 2x equals 6. We did not change a thing with that second equation. Now, normally you only have to multiply 1, but eventually, harder math classes, you might have to multiply like the top by 2 and the bottom by 3 in order to make it work out. It's not really a big deal. Okay, and then we get to eliminate. The x's, they go bye-bye. They are eliminated. That is why it's called elimination. 6y and a positive y, that gives us 7y. Positive 8 and positive 6 give us a positive 14. If I divide both sides by 7, I end up getting y equals 2, and I am happy.
Wait, why are you so
Okay, so again, the first thing we did was line everyone up. We had the x's in a column, the y's in a column, the numbers in a column. And then we said we want to eliminate, that's why it's called an elimination, we want to eliminate one of the variables. Maggie voted we eliminate the x, so that's why we multiplied everyone in the top equation by 2. And look, elimination happened. The x is left. We eliminated someone. So you've done elimination wrong if no one gets eliminated. Okay, so the x is left because 2x and negative 2x, they canceled out. 6y plus y is 7y. 8 plus 6 is 14. And then I had to divide both sides by 7, and I got y equals 2. Are there any questions about this? We're going to do a couple more. Okay, so if I got y equals 2 now, what do I do? You got to plug it in to get x, because for our solutions, we're looking for an ordered pair. So Ms. Compton still circled the y. That's not all we need. We still need an x. You can plug it in either equation. I'm going to go with the bottom one, but it doesn't matter. So 2 minus 2x equals 6. I subtract 2 from both sides. I get negative 2x equals 4. I divide both sides by negative 2, and I get x equals negative 2. So my answer is negative 2, 2. Okay, again, some problems are going to make you solve by elimination. They're going to say in the directions, solve me by elimination or else. But the reason, if you're given the option, you would want to use elimination is because it didn't look easy graphing, it didn't look like an easy substitution, and elimination was a little faster. I think elimination is the coolest, but I'm good at keeping up with my work. You know how, like, you're like me, some of you are. I'm a creature of habit, and I write all my lines over and over and over again. If you're not good at stuff like that, like keeping up with your signs, then elimination is not going to be your favorite. Are there any questions about this example? Okay, then we're going to do the elimination example on the solving with one solution. And let me give her a page. What is this? We're going to do the one solution. We're only going to do elimination. Okay. Does this look like an easy elimination problem? If you got to choose, would you choose elimination for this problem? No. Well, most people would think no anyway. Why? What should you do instead? It does look like a good substitution problem. Why is that?
Because you already have y.
You already have y all by itself. Plus, even if you don't want to do substitution, this is a pretty easy graphing too, because you just got to subtract x on that second equation, and it's in y equals mx plus b, and you can jam. So no, I totally get, normally in life, you would not want to solve this problem by elimination, but that's what the directions say, so we got to follow directions.
How you line them up?
That is the question. So our first step is we got to line them up. In the last problem, they were already lined up. They're not lined up in this problem.
I say, oh, sorry.
Go ahead, tell me.
I say get the second equation at y. What if it is at 1?
We could do that. Is everyone okay with Maggie's suggestion? Okay, we can do that. So she wants to, on the second equation, it was x plus y equals negative 2. She wants to subtract x from both sides. So it's y equals negative x minus 2. But you realize the rest of us are now very tempted to just graph this and graph that and figure out the answer without doing elimination. Now that would be very smart. You could always check yourself for that. But again, the directions say elimination, so we got to do what it says. Okay, so now we have the equation y equals 4x plus 3. And with Maggie's help, the second equation has become y equals negative x minus 2. She had a good suggestion because we're really close. This is a tiny box. We're really close to being able to cancel someone out. We would love to cancel someone out. Who can we cancel out? Okay, so we could get rid of the x. We would just multiply everyone in the denominator by 4. That's a great idea. There is another suggestion as well, though. If we wanted to get rid of the y's, what would we need to multiply the bottom by? Negative 1. So what's going to be easier, multiplying everybody by 4 or everybody by negative 1? Negative 1. That's what I think. But if you want to do the 4s, you're still going to end up with the right answer.
But everybody, do you mean like everybody? Like,
no, you can do it your way. You can do it your way. If you'd rather multiply everyone in the denominator by 4, you can. So I'm multiplying everyone in that bottom equation by negative 1 because I'm going to cancel out the y's. But if you multiply everyone in the denominator by 4, you're going to cancel out the x's. We're still going to end up with the same ordered pair. We're just going about it different ways. Okay, so we didn't mess with y equals 4x plus 3. It stays the same. But we did mess with that second equation. We're going to change everyone's sign because we're multiplying by negative 1. So we're going to have negative y equals positive x plus 2. Are there any questions about this? Okay, well here's the most important step. It's called elimination because someone gets eliminated. If you end up here and none of the variables cancel out, you've done something wrong. So, boom, the y's cancel out. Y minus y is 0, so 0y. 4x plus x is 5x. So I have 0 equals 5x plus 5.
wait.
Now, I normally wouldn't write the 0. I normally wouldn't. But Maggie had us rearrange this equation so the x's and the numbers were on a side and the y was on a different side. So when we got rid of the y's, that left side was empty, so I have to put the 0. If we could go back in time and start this whole problem over again, should I maybe have...
I was thinking that we could subtract 4x and put it on the other side and put 4x plus y equals 3.
Then they're not going to be lined up. Okay, what I would have done differently if I could go back in time and fix this wrong is normally we like to do, no, it's not wrong. We're still going to end up, no, still going to end up with the same answer regardless. I normally, creature of habit, do an x column, a y column, and then the numbers. So since that second equation was already x column, y column, numbers, I probably would have rearranged that first equation so it was x column, y column, number. That might have made it all a little easier. Again, this is why people don't like elimination. Because Ms. Compton said, first of all, you could have changed 2 different equations. You could pick either one. And then you can pick which variable you're getting rid of. You pick which one you're getting rid of. I picked y. You could have picked x. So people don't really love elimination. Okay, continuing on with the mess we sunk ourselves in. It's fine. If you subtract 5 from both sides, you have negative 5 equals 5x. If you divide both sides by 5, you get x equals negative 1. We've not done anything wrong because we still solved. We still ended up getting x all by itself. We can plug it in and solve for y instantly. Not a problem. Now, here's one more thing you can pick on your own. I'm going to plug it in, that top one. You could have plugged it in the second one. You can plug in either one. Okay, so it was y equals 4x plus 3, but I got x was negative 1, so I'm going to plug in negative 1. So I have y equals negative 4 plus 3, so I get y equals negative 1. So my ordered pair is negative 1, negative 1. Negative 4 plus 3. Okay, and Maggie said something really smart right then. No, you said something really smart right then, which was I did not get that. again, that's why I really love solving systems equations. If you question your sanity of am I actually doing elimination right, well, first of all, did someone get eliminated? If so, you're probably doing it right. And second, we already know that this is almost in graphing form. Heck, you already helped me put the second equation in y equals mx plus b. I can graph both, make sure they cross at -1, -1, and then I'll know I'm right. So -2 of 1 over 1. Miss Compton, you can't do that today. So they really did cross when I graphed the two equations. They really did cross at -1, -1, so I know my work is right. It's just like when you were doing your substitution with your partner and their graph needed to match your work. Same thing happens with elimination. The graph needs to match your work. The solution needs to be the same point. I swear we will do more elimination examples tomorrow. As for now, go back to your partner activity. If you're done with your partner activity and I've already approved of it, let's get you a head start on the next thing. It is, let's do this one. I put it on the podium if you've already made your partner thing. If I'm not seeing your partner thing, you want me to see it before you leave, or else it's going to be due tomorrow, and trust me, Will and Jacqueline and Kimberly can vouch. I'm pretty mean on it. I'll pass it back to you if I don't like your work. So, good luck. The one that Will and Aaron and them are getting, I'm pretty sure it says solve any way you want. So if you didn't like elimination right then, don't use elimination. You figured it out? It looks like it. Yeah, it took a while. They're giving you a different thing to do. You just got that. That's right. Very good. So substitution candidates, not your favorite. Anytime it says you get picked, don't do substitution. Oh, why is there only one? It is on the sheet. Oh, I should probably stop recording. We're not doing anything.